Hi, this is chapter 13, number 37, and 37 states a satellite of mass 200 kilograms is placed in Earth's orbit at a height of 200 kilometers above the surface. A. What is with a circular orbit, how long does the satellite take to complete one orbit? B. What is the satellite's speed? And C. What is the minimum energy input necessary to place the satellite in orbit? Ignore air resistance, but include the effect of the planet's daily rotation. So first we want to list our givens. We're given that the mass of the satellite is 200 kilograms and the distance above the surface is 200 kilometers. We must find the time it takes for the orbit, the velocity of the orbit, and the minimum energy needed to put it into orbit. So we start with the force of gravity is equal to the force of Earth. That's what we need. So we use the equation mv squared over r equals gm, which is the gravitational constant, me, which is the mass of the Earth, over r squared. This formula reduces to v rad gme over r. And we also know we have to use the formula for the period, which is 2 pi r over v. And if we plug that in for v here, we get 2 pi r square root of r over gme. Now for part A, we must find the total radius of the Earth, which is the radius of the Earth plus the 200 meters that the satellite is at. So that'll be the distance that we'll use for the radius of the object. Thus, the period is equal to what's given below as we plug in each equation. And we get t equals 5.3 times 10 to the third seconds. And if you convert that, it becomes 1.47 hours. Part B, we're solving for the velocity, and the velocity is equal to the square root of the gravitational constant times the mass of the Earth over r. And if we plug in the numbers we already have for this, we get 7.79 kilometers per second. Finally, part C, solving for the minimum energy it takes to put the object in orbit. We have the kinetic energy plus the potential energy equals the initial kinetic plus the initial potential plus the energy input, and the energy input is what we're solving for. So the equation we'll need for this is shown below. 1/2 mv final squared minus 1/2 v initial squared plus the gravitational constant times the mass of the gravity over r, and minus the negative gravity times the mass of the Earth, mass of the satellite over r initial. With all this equation shown, we got to plug in the numbers that we have, and once you plug in r initial, v initial, and substituting all the forms into that equation, you'll come away with a number for the minimum E input of 6.43 times 10 to the 9th joules.